All right, so we are on lesson 4-4 for AP Calculus. Today's date is Monday, October 28th. Let's see what's going on here. October 28th, 2019. 2019. Mean value theorem applications is the name of the game. What is our objective today?
Use the definition of the main value theorem to solve problems.
Yeah, so MVT rears its ugly head yet again. I shouldn't say ugly, it's a beautiful head. Mean value theorem is pretty fun. It's a lot more simple than a lot of other theorems that you'll learn in calculus. But at least for AP calculus, there's just those three that you really need to know. But when you study higher levels of math, they get really, really difficult. Although Rolle's theorem is even easier. Anyway, random tangent, let's come back to the mean value theorem. Tell me, what is the mean value theorem?
It's slope.
It guarantees slopes, and what does it need in order to guarantee slopes?
Be continuous.
Differentiable, which implies that it's continuous. Exactly. So it does need to be continuous also, because that's part of the definition of being differentiable. What about the actual notation? Does anyone remember where you have like f prime of c is equal to blah, 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 blah? Do we remember that definition? Because you definitely need to have that memorized, especially for today's lesson. You're really, really close. There's no more primes. Just primes on the left, no primes on the right. So just f of b minus f of a. That's a bad a. There it is. F of a all over b minus a. Thank you, Stego. So this is the definition that we're using over and over again. Generally speaking, what can I call the left-hand side? What is this saying? F prime of c. F prime is just the
slope of the specific.
Yeah, the slope at a specific point. And it's not the slope of the secant, it's the slope of the, what's the other word? We don't use secant, we use, starts with a t. Yeah, so write it down. This is the slope of the tangent. And we know that point C, usually we say that point C is somewhere in between A and B. So somewhere in between A and B on this graph, I'm going to have like a point C here, here, or here. Somewhere in between A and B, I'm going to have a slope of a tangent. What can I say about the right-hand side? How could I kind of define the right-hand side?
The average slope of the equation.
Ooh, yeah, average rate of change, right? I'm going to also call this thing slope. What is it the slope of? It's not a tangent line, it's a slope of secant. And that secant, or the average rate of change, as Claire said, is the secant line that connects A and B. So it's the secant, I guess, from A to B. So I want to show you graphically what's happening. I think I showed this once, maybe not. I'm getting mixed up from all the years I'm teaching this now, which is not a good sign. But let's start with the secant line from A to B. And you get to just sit back and relax and eventually take notes later. But I have a secant line from A to B. There it is. We all agree that's a secant line. It touches twice. What I'm going to do now is I'm going to say, okay, well, where does this slope also exist? As a tangent line. So I use technology and I move this around. Is it tangent? I can't even, it's not tangent there. Where is it tangent? Where does it touch only once? Right, boom, right there. And that is one very, very specific point. And that point is right there. What mean value theorem states is that this slope of the tangent happens at least one time for the slope of the secant. So if I move the slope of the secant around, I have to hit that at least one time. And that does happen at a specific point. And if I come down and make a kind of a dashed line, do I have the ability to make this a dashed line? No, I'm going to go ahead and freehand it then. This dashed line that comes down here, this x coordinate is c, and then obviously the height is f of c. But the slope here is the same as the slope of the secant line. Am I confusing anyone? Ask questions. Let me know that you understand somehow.
Want to repeat that? I kind of spaced out.
All right, so I started with the secant line from A to B. So I grabbed this line. This was the secant line from A to B. If you move it, it should be a tangent line somewhere. Where does that happen? Right there. I can find this point C. That's what we're doing today. Where is C? You should be able to mathematically determine where C is. Essentially what you're doing graphically, no, don't move you around. What you're doing graphically is you have this secant line and you move this to the graph where it's touching only once. So graphically, it's really easy. It's really fun to play around with it. Mathematically, it's a little bit more difficult. You actually have to use this definition of the mean value theorem and then set what you know. You probably know B and A and F of B and F of A, and then you'll have to solve for C, and you'll have to take the derivative because that's F prime, and then you'll have to play around with it until you actually get an X value out for C. All right, so we know what's happening graphically. Let's go ahead and do it numerically. I'll give you 2 examples, and then that's it. All right, so first example. We're looking for the number C. Again, let me come back to my pen. We're looking for the number C, just like we had down here. What is the X value that satisfies the mean value theorem where I have this function? The function is x to the power of 3 minus x to the power of 2, and it's on the interval from 0 to 1. That's all the information I'm given. An equation and an interval. That's it. It seems like I'm not given enough information, but I am, because we can say that this 0, is that going to be A or B? You get to choose. We'll call that A, therefore 1 is going to be B. We were given A and B. We can find f of A and f of B as well. So I'll pause here. Make sure that you have this graph written down. If you haven't done that already, make sure that you have that tangent line. We're going to come down and we're going to find all of the information that this is giving us. Like, obviously we should have all the information on the right because we're trying to find C on the left. So let's go ahead and find f of b, because that's something that's on the right. In fact, maybe, yeah, let's just say, what is f of b? F of b means I'm plugging in b, I'm plugging in 1 into this equation. So that's going to be 1 to the power of 3 minus 1 to the power of 3, which is equal to, what? What's 1 to the power of 3? Oh, 1 to the power of 2. What's 1 to the power of 3 minus 1 to the power of 2? 0, because it's just 1 minus 1.
Isn't it, but doesn't the second one becomes positive because of the power?
So I agree that this whole term becomes positive, but I'm still subtracting a positive.
Okay.
Yeah, you have to be careful if you're negative. If I had this equation, though, then it would be 1 plus 2. I agree. So this is going to be 1 minus 1, which is equal to 0, and therefore let's do f of a. Then f of a is pretty straightforward. You can probably do it without even writing down the math. F of a is... Again, it's going to be, I'm plugging in 0 into each of these x's, so I can write it all out. It's going to be 0 to the power of 3 minus 0 to the power of 2, which is equal to just 0.
Oh, so you plug in the intervals to each of those, to the equation.
Yeah, exactly. I'm just trying to find all this information on the right. I'm using this definition of the mean value theorem. So I have all the information on the right. I have a and b, obviously. A and b for 0 and 1. I have f of b, 0. F of a is 0. I'm missing the c, obviously, because I need to find it. But I'm also missing an f prime. I don't have f prime right now. I just have f. So let's find f prime. So f prime of x is equal to what? Take the derivative.
3x squared
3x squared
minus 2x.
minus 2x. Okay. Therefore, f prime of c is going to be what? F prime of c, I'm just going to change all these x's for c's. Yeah, if I change the x to a c, that means I'm changing the x to a c. So there it is. 3c squared minus 2c. All right, so far so good. This is a good time to ask questions because now we're about to start plugging things in and making some magic happen. Nope, we're good, we're good. I'm still writing down the problem, don't even have time to think, so maybe I should wait. No. Okay, so let's go ahead and use the definition. So I'm going to come over here, I'm going to rewrite the definition. You're going to be rewriting this a lot today for the homework. Write out f prime of c is equal to f prime of c is equal to f of b minus f of a all divided by b minus a. And I will make a note here as well. If you do f of a minus f of b all over a minus b, if you switch them on the left and right, you'll still get the right answer. So from here, let's go ahead and make our substitutions. We know what f prime of c is. So f prime of c on the left-hand side is what? Shout it out.
3c squared minus 2c.
3c squared minus 2c. On the right-hand side, shout it out. F of b is
0.
0. F of a, 0. B is 1. A is 0. So essentially we have this equation that says and I ran out of room, so I'm going to come back down here. 3c squared minus 2c is equal to 0. Or 0 over 1, which is still 0. And I can write that off to the side if you don't know that. 0 divided by 1 is the same thing as 0. 0 divided by any number other than 0 is 0. Okay, how do I solve this thing? If this was like a problem in Algebra 1, which you do see in Algebra 1, how would I solve?
You square root.
If I square root, you're going to run into some difficulty. Let's try using an F word first.
Take the F prime.
Factor. There it is. So if I factor this thing, what does 3c squared minus 2c factor as?
C minus 3C minus 2.
3c minus 2 is equal to 0. And when I solve that thing, I get two values. Because I set c equal to 0,
It's 0.
so that means c is equal to 0. And then I set this other one to 0,
2/3. Right.
and yeah, c is equal to 2/3. Good job, Gio. All right, so what are our answers?
0 and 2/3.
There it is, 0 and 2/3. I guess I need to rewrite this problem. What I should do next time is I should get rid of this. I'll make a note for myself. Get rid of the equal sign, so that way one of them is eliminated. You have to check the interval at the very end to make sure that you're in the right interval. Technically, 0 is included, so 0 is an answer. So we can say, yes, that was an answer, and we can say, yes, 2/3 was an answer. But I should next time make it so that one of them is not the answer, so you actually have to go back and check, oh, are those both on that interval between 0 and 1? Because what if you got c is equal to 9? That wouldn't work. Oh, yeah, that wouldn't work because these are x values again. They're the x values in between a and b. You have to make sure at the very end to check that these values are still in the correct interval, but they both were. Let's try another one. Example number 2. You guys walk me through this one then.
So we had to find F of A and F of B.
Yep, so let's do that. Here's f of b, here's f of a. What is f of b? It's 1/2 6 quantity squared plus 6. Well, what's 6 squared? And I'm going to take half of that. And I'm going to add 6 to 18. All right. What about f of a? Careful. So I'm f of a is 0, b is 6. So if I plug in 0, 0 squared, Geo is
0.
times 1/2 is
1/2.
0 times a half is
Oh, 0.
0, plus 0 is,
Oh, 0.
very nice. So we have f of a, and then we also know what b and a are. Let's find f prime of c. Let's skip a few steps. F prime of c is going to equal what? Make sure that you replace all the x values with c.
It's going to be 1.
So the 2 multiplies down, so it becomes 1 up front. I agree. 1,
X
1c to the power of,
and
1, yeah. Plus
1.
1. So this actually simplifies to just c plus 1. All right, so write down your definition of the mean value theorem. F prime of c is equal to what?
F of A minus F of B.
You can do it that way if you want. Normally you write f of b minus f of a. Just make sure that the bottom matches up. So if you did f of a minus f of b, then do a minus b instead of b minus a as well. All right, and then make your substitution. So what should I have on the left-hand side? Shout it out.
C plus 1.
There it is. C plus 1 is equal to 24 minus 0, all divided by 6 minus 0. And what's 24 divided by 6?
3. Wait,
4.
4.
All right. So then I get the equation c plus 1 is equal to 4. Therefore, c is equal to,
5.
careful,
3.
3. Is 3 the answer? Is it still in the interval?
Yes.
It is in the interval between 0 and 6, so C equals 3 is the answer.
Is that it?
That's what you're going to be doing over and over today. Ask me questions. Then give me a fist of 5. How well do you think that you can do this objective of using the definition of mean value theorem to solve problems? All right. I see a 4, a 3, and a 5. Yeah, good luck on the homework.